Hello, this video is a demonstration of our submission for the DataView Challenge 2016. Our team comprised of 4 members, namely Mayur Saxena, Aniya Aggarwal, Varun Parashar and Nishtha Madaan, all from IBM Research Labs, India. Without wasting more time, let us start with the demonstration of the web app. Let us start with question 1. The question 1 says, which diseases are more prevalent in a given area? For our analysis, we have chosen state as the desired area. As you can see on the left hand side of the screen, you have the map of India with each state colored at a very different gradients of green. The one which has a darker tone of green has more number of cases of diseases with respect to the number of people in that area. As you will hover over a given area, a pop-up will appear which gives a detail about the state. For example, the disease gradient, capital, population, area, growth, and on the right hand side you can see a bar graph comes up what all diseases are prevalent in the area. As you can see in this case, acute respiratory infection cases are maximum, which are followed by acute diarrhea cases, then malaria cases, followed up by Japanese encephalitis and viral hepatitis cases. Similarly, as you will hover over other state, similar level of interaction will be visible. To know about the methodology which has been employed in the analysis, just click on this methodology button and the pop-up will appear showing all the details. Let us start with question number 2, which has 2 subparts. First, which diseases have been better controlled in India, and the next one is which states have been better than others. For this, we have again the map of India on the left and a bar graph on the right, which presently is showing the statistics with respect to India. Now, as you will hover over different states, the bar graph will show us various attributes like the number of cases, the registered number of cases, and the number of cases cured. So, as you will hover over, there will be the interactive changes that will be observed in the bar graph. The bar graph is pretty flexible, as you can vary between the type of graph you want, and even you have the flexibility to choose the year which you want to select. Now, in order to see which states have done better than others, so you just click on the map of India and you have a pop-up option which on the right hand side, wherein you can select the disease for the analysis. For example, let's take acute respiratory infection. So here it will show the top 4 states who were successful in reducing the number of cases. That is, the one having the darker shade of blue was best in performing, or rather best in reducing the number of cases than the lighter shades of blue. Similarly, this can be further extended for the cured disease cases. Here, the one which is having the darkest shade of green was more successful in curing the number of cases that happened for the case of acute respiratory infection. In order to see the methodology which has been employed, just click on the methodology button and the pop-up will appear showing the details. For part 1 of the question, in order to analyze which diseases have been better controlled in India, just scroll down and you will see a line graph showing, like in this case, the diseases case rate. Here, this is a temporal graph from 2000 to 2011. The one which has a positive graph means that here the disease was not controlled because the rate kept on increasing, while the one having the negative slope means the disease was controlled Similarly, for the case of the cured disease case rate, so the one having a positive slope means even if there were some cases, they were cured better if they have more positive slope in comparison to the one which is having a negative slope. Next up is question number 3, which also has two subparts. First, how much money has been allocated to tackle specific diseases compared to others? And the next part is, which regions do better than others in controlling diseases relative to money? So let's start with question 3 part 1. So here we have considered the 9th plan and 10th plan for the analysis. On the right you can see the pie chart which shows the distribution of the money over various diseases, and on the left hand side you can see the bar graph showing the various statistics. You have the flexibility to switch between a grouped bar graph and the stacked bar graph. To know the methodology that has been employed and the datasets used, just click on the methodology button and the pop-up will appear showing all the details. For the second part of the question, which is which regions do better than others in controlling diseases related to money, so you have this option, just click on it. Cool. So here select a disease from the drop down, so let's say acute respiratory infection. So herein you can see that on the blue graph means the number of cases, and the orange line graph shows the expenditure that has been made. On the bottom you have the acronyms for various state, and as you will hover over, you will see the details with respect to the expenditure made by a given state and the details of the count of the cases that have been registered. Similarly, you have the option to switch from 2011 to 2010 or vice versa. Similarly, you can select the number of cured cases or the death cases for the same level of analysis. In this case also, in order to know the methodology, just click on the methodology button and you will see all the options. The last part of this analysis, which is question number 4, was, is there a relationship between waterborne diseases and their relation to water pollution? For that, let's switch to question number 4. Here we are tried to show the association rules which we have achieved, creating clusters over the various factors of diseases and pollutants. Each circle represents a particular feature, be it disease or the pollutant level, and the size of each circle is proportional to the dimension, or rather the value of that feature. So like this, in this circle the level of pollutants is pretty high, which is associated with a high level of acute diarrhea and viral hepatitis. Similarly, various other clusters have been observed and rules were derived. So this circle represent a rule, and each in group of circles which are closely attached to each other imply they are highly associated with each other. To know what is the inference that is achieved from all these circles, just click on this inference button and you will see that two of the inferences, the main inferences that have been achieved, that is low count of disease cases implies low water pollution, moderate or high water pollution implies moderate count of disease cases. In this case also, in order to get the methodology of the analysis, just click on the methodology button and you will see a detailed analysis. Thank you and hope you liked our web app submission.